So before we go any further, I just want to talk about the fact that when we draw electrical circuits in a physics class, we don't attempt to draw that circuit physically. So for example, suppose I had a battery and I had a light bulb and I had an ammeter to measure the current, and I had a switch to turn that current on and off. I would not try to draw a picture of how those wires and things are connected to one another. What I do is I abstractify that circuit diagram into a collection of symbols and the simplest possible version of those objects that I can. So when we draw a circuit in a physics class, we use a certain set of symbols, and there are lots of these, and we won't need them all in this class. But there are a few that we will need. One is that when we draw a battery, we draw these two unequal lines, and I will usually label it, but your book doesn't always. The long line represents the positive terminal of the battery, and the short line represents the negative terminal of the battery. And you'll also sometimes see this referred to as a source of voltage or potential difference, or this term that we sometimes use. It's a very antiquated term, but physicists haven't let go of it. EMF, which is short for electromotive force, which is a very 1800s sounding bit of terminology. But for some reason we still use EMF, and sometimes you'll see this cursive E standing in for voltage. And we'll see that a lot in the next chapter when we talk about electrical currents. A resistor we usually draw as the zigzaggy line. And as we'll talk about in the next video, the reason for that is the longer a wire is, the longer its resistance is. So you can think of this symbol for a resistor representing a bunch of wires squished up into a really, really small space. The other thing that we'll see a lot are capacitors later on. A capacitor is drawn as two parallel plates. Easy to confuse with a battery if you're not careful. The battery is always two unequal. Capacitor, always two equal sized lines. And that takes us most of the way through the stuff we'll be doing in this class. Meters, an ammeter is something that measures current. Current is measured in amps, but the thing that we measure current with is not an amp meter, it is an ammeter, which measures current. And a voltmeter measures voltage. A very old word that you will sometimes see used in place of voltmeter is a galvanometer. Galvanic used to be an old word that was used to refer to batteries, galvanic cells. I don't even know the origin or the etymology of that word. I should look it up. But if we look at when we talked about Georg Ohm, the work where he stated Ohm's law was a work called The Galvanic Circuit Investigated Mathematically. So galvanometer is an old word. So there are other symbols for, later on we'll see inductors. An inductor is a coil of wire. We use this swirly shape to stand for an inductor. There are also symbols for switches and semiconductors and variable resistors. If you're going to go into electrical engineering, it behooves you to learn all of those symbols. The other thing to talk about really, really briefly is that when we draw an electrical circuit, again, we don't attempt to represent the shapes of the wires as they are in space. We just represent them schematically in the simplest way possible. What that means is you have to get sort of good at realizing what circuits are equivalent to one another. For example, suppose I've got a battery. Oops, battery. I'll hook it up that way. And I've got it connected to a resistor, and then another resistor, and then another resistor. One of the things you have to realize is that this circuit, let's say this is a 1 ohm resistor and a 2 ohm resistor and a 3 ohm resistor. That circuit is exactly the same, well, let's do it like this, as this circuit. One ohm, 2 ohm, 3 ohm. My omegas get really sloppy sometimes. Oh. In other words, the circuit goes from a battery, from the negative terminal, actually, if we want to start the circuit from the positive terminal, from the positive terminal of the battery through a 3 ohm resistor, and then a 2 ohm resistor, and then a 1 ohm resistor, and then back to the negative terminal. This circuit goes from the positive terminal through some wire, through the 3 ohm, the 2 ohm, the 1 ohm resistor, and back again. If I want to draw that same circuit like this, through the 3 ohm resistor, the 2 ohm resistor, the 1 ohm resistor. That again is the same electrical circuit. They are not different from one another, despite the fact that we've drawn the resistors in different places on the rectangular wire. I guess I forgot to mention, it should be obvious, I hope, that the symbol we use for a wire in a circuit is just a straight line. So getting to the point where you can recognize serial and parallel circuits as being identical to one another is just something that takes practice in looking at a lot of these. If you've got a more complicated circuit like a parallel circuit, suppose we have something like this. We've got our battery. We'll do it down here. Two resistors. Okay, so let's say this is a 2 ohm resistor and a 4 ohm resistor. You've got your battery. Let's say this is a 9-volt battery. And you can go from the negative terminal of the battery to here. The wire splits. Part of the wire goes through the 2 ohm resistor. Part of the wire goes through the 4 ohm resistor. Those two sections of wire come back together, and the circuit continues back around to the positive terminal of the battery. Those two resistors are said to be in parallel with one another, meaning they're on two branches of a circuit where the electricity, the current branches at this point, and some of it flows through one and some of it flows through the other. That circuit is exactly the same as if I had drawn it like this. Two ohms, 4 ohms. Okay, it looks pretty different in terms of the way it's drawn. But if you look at what happens to the circuit from the negative terminal, we go through a wire, we hit a point here where it splits. Part of that current goes through the 2 ohm resistor, part of that current goes through the 4 ohm resistor. This comes around here, it comes back together and goes back to the battery. So these two circuits are the same. So recognizing circuits and the sort of topology of circuits, how they're connected to one another, is going to be really important when we start looking at more and more complicated circuits with a lot of resistors and have to redraw circuits as being pieces of circuits in parallel or in series with one another. So just getting used to looking at these diagrams is going to be really, really important, and we're going to have to practice lots of these problems over the next couple of weeks. So that's just a really quick introduction to some notational stuff, and now we're going to get back to talking about resistance on the microscopic level.